In this video, we want to find the solution to this system of nonlinear equations. Now, it's not necessary to know what the graphs represent because what we're asking for is the points of intersection of these two equations, or graphs of these equations. So the first one's a circle, the second one's also a circle. So if you sketch the graph of two circles, you could get something that looks like this. They don't intersect. So you would try to solve this, you'd come up with a contradiction, something like -2 is equal to 5, which says no solution. Or you could have something that looks like this. You have two circles, they intersect at this point here and this point here. So you should have two solutions, ordered paired solutions for this. Or you could have a circle like this, and then another one like this, and they touch at one point. You have one ordered pair. So you take the same approach if you were solving, say, a linear system of equations, where the equations represent lines. So we can use the method of elimination, substitution, or a combination. So here what I'm going to do, I'm going to try to eliminate one of the square terms. So I'm going to say, hey, let's multiply the first equation by -1. Multiply through and then add. Okay, so -1 times x squared is a -x squared, and an x squared, those would cancel. -y squared, here if I multiply by -1 and a positive y squared, those would cancel. And then on the right side, I left with -1 times 8 is -8. And then of course on this side, when I add these up, the only thing I would have is a 4y. So I'd solve this for y, divide both sides by 4, and I'd get y, the 4's would cancel here, -8 divided by 4 is a -2. So now we got the value of y here. So what is the value of x? So we can just say here, if y is equal to -2, what's the value of x? And you can plug in -2 in any one of these equations. I always like to pick the simpler one. So the first one has less terms, so I'm just going to say, all right, x squared, using the first equation, plus y squared is equal to equal to 4, to 8, I'm sorry. So x squared plus y squared is equal to 8. And then we're going to substitute a -2 for y. That's going to be squared equal to 8. So x squared would equal to, this is -2 squared is 4. Take it over to the other side. So subtract the 4 from the 8 gives me a 4. And then it's out for x. Take the square root, plus or minus. And I get x is equal to plus or minus 2. So my solution set then would be y equal to -2. When y is equal to -2, x can have either value of 2 or -2. So I'll put a 2 here. -2 again, another value for this one can be 2. And I'll put this in a solution set. So the solution set to this system of nonlinear equations is the ordered pairs 2, -2, and -2 here. Two possible values at -2 is 2 and -2. So if I were to graph these two equations, they would intersect at the point 2, -2, and -2, -2. Now keep in mind, whenever you solve an equation, there's always a possibility that there's no solution. In some cases, there could be an infinite number of solutions. So you can always check yourself. So let's see, put a 2 here where the x is for the first one. And remember, just because it checks the first one, you still have to check the second one. So 2 here squared is 4. 2 squared here is 4. This is going to be 8. So 2 squared is 4. And -2 squared is 4. 4 and 4 is 8. And we got 8 equals to 8. Then you test the other one. Well, -2 squared here for the x and -2 squared for the y. It's going to get 8 again. I want to get 8. But now let's check the other one. So -2 squared here. -2 squared, that's 4. And 4 is 8. -2 here for the y. It's a -8. That's 0. Okay. First one also. Check the first ordered pair. 2 squared is 4. -2 squared is 4. 4 and 4 is 8. And then a -2 here for the y is -8. 8 minus 8 is 0. So this confirms that this is the solution. Thanks for watching. We'll see you next time.